now.
Yes.
Hi everyone. I'm Anamika, and on the other side we have Yayati Gupta, and we welcome you all to the final interactive session. We hope you have learned a lot of things through the course, and we hope you will be able to use these concepts in your work, in your research. Um, Before we start, we would like to update you on the cancellation of the programming exam. We hope you have received the email. So, due to some operation problems in the portal, we would not be able to have this exam, which was supposed to happen in the evening. So, so there is a slight change in the evaluation scheme, and that is earlier the proctored exam, the final exam, was supposed to carry a weightage of 65%, which will now be carrying a weightage of 75%, and the rest remains the same. So we will not be considering the marks which you people scored in the programming exam, which happened earlier. We will be ignoring that, and everything else remains the same. That is, 25% weightage will be given to the assignments, and out of that, as you know, 15% is for the quiz and 10% is for the programming assignments. So everything else remains the same, only one difference, that we'll not be considering the programming exam due to the problems in the portal. So many of you were interested in knowing about the research directions in this domain. So Yayati will now be briefing you about various directions that people have been taking, and we can pursue in this domain of network science. Over to you, Yayati. Can you please carry on?
Hi everybody. So before starting, first of all, I would like to know how many people are here. So I can't see anything in the chat window. So can you please type a hi there if you are present? Mm, okay, perfect. It seems that many people are not around. So I'll just carry on. I'll give you a. So maybe you might be watching it later. So I'll just carry on. I'll give you a brief overview of what are the possible research directions you can pursue in this field. So many candidates have been asking us from time to time that what kind of a research they can carry out in social networks. So probably kind of they want to know a starting point from where you can pick it up and perform research over here. So I'll now share my screen with you so that I can give you a presentation over here. Just give me 2 minutes. Okay, perfect. So, um, okay, so let us start from here. So I'm going to tell you some of the possible research threads in this area. So these are totally from my perspective, how I have seen this subject being a research scholar. So the research threads I'll be discussing with you will be a little bit inclined towards my own research interests. However, I've taken care of that I can put certain other research threads also here, which my colleagues are working on and the members in my team are working on, so that I can give you a broad viewpoint about it. So, okay. So I'll be starting off with the information diffusion. So that's my research area, and then later I'll tell you about more. So the very first thing is the information diffusion in synthetic networks. So over this course, we have looked at various synthetic networks, right, such as random networks, scale-free networks. So one can try studying about how information diffusion in these networks look like. For example, if you leave an information on a random network, how will it traverse, how will it propagate? And if you leave something on a scale-free network, how will it propagate? Again, you can study it from a theoretical perspective, so you can actually use their degree distributions and something known as a generative functions to understand it very nicely. And then you can look at the various thresholds these networks have. So thresholds basically tell you how quickly the information propagate in such networks. So again, I'm giving you a very broad overview. So to have a complete picture of how this is done, you can go to Google Scholar and you can search the relevant papers, and then maybe you can look at certain loopholes which you can fill. um, and then another kind of a structure is community structure. So again, as compared to then we have random networks, scale free networks. Similarly, we have a community structure over here. So in case of random networks and scale free networks, I want to make sure whether I'm audible or not. Okay, perfect, I'm audible. Okay. So in the case of community structure, you can kind of more do an experimental kind of study. So here maybe you need not do something which is very theoretical. Actually, your intuition tells you that on something which is a scale-free network, information will spread quite quickly as compared to a random network, because we have hubs here. If you talk about a community structure, then also intuition tells you that maybe if some information starts spreading from here, it will be trapped in a community. But again, then you can experimentally prove it. So that's a possible research direction, and this research direction has been actually pursued. A lot of work has been done here. So now I'm little bit concerned about the BTech students. So for BTech students, they might not actually delve into such deep topics which requires a lot of literature review, and you don't want to do a 5 year kind of a research or something. So you were actually interested in knowing how you can do small projects maybe. So I'll also come there in between and tell you. Okay. Another thing is the information diffusion in real world networks. So real world networks, they substantially differ from our synthetic networks, and information diffusion in real world network is quite complex as compared to what is there in synthetic networks. So in real world networks, we have certain things playing their role. For example, influence. If an influential person says you something, you are more likely to hear to him. So such things we do not take care of in when we talk about the synthetic networks, but when you talk about real world networks, there are a lot of factors playing their role there. So you can actually look at it from a sociological perspective, from a psychological perspective, from an economics perspective, and then create different kind of models over here. So one of the studies which I have done is more towards the psychological perspective of it, and then addressing it through computer science. But to gain a complete picture of how it is modeled in different ways, again you need to look up some papers which have been done in this direction. Okay, so this is something which everybody can do, topology of real world networks, and there are actually no strong prerequisites required for it. So we have already seen some factors in the topology of real world networks. For example, they have a power law, they are scale free, and then they have communities, they have core periphery structure. But again, especially for BTech students, or maybe if you want to do a small project, you can play around with the data. So we have in the second week, we have discussed about various data sets which are available online. So you can actually fetch one of those data sets. So probably maybe a road network or a citation network, or maybe a network of some other form, a computer virus which is traversing over computer, and then you can try to see what is the topology there. So there are a whole lot of topological factors. So you can look at the clustering coefficient, betweenness, or which node is at the center of this network, and stuff like that. And it will be rather all the more interesting if you want to do a project, let's say in your college or somewhere. It will be very nice if you can actually make a network out of your own classroom, which exists in the real world, and then you can play around with this data. Look at which is the most popular person in your class, or which is the person having the highest degree, and definitely make some certain strong conclusions out of it. So research in this direction actually doesn't have lot of prerequisites. It is totally up to your own creativity. How do you model problems and how do you solve them? Another problem is influence maximization. So I'll just state the problem statement here. So let's say you are running a company and you want to advertise a product. So these days all the companies are using social networks to advertise their product. So let's say here is a social network shown to you, and what you want to do, you want to maximize the sales of your product, and your company has finite resources, so you cannot indefinitely advertise your product to the people. So let's say you have some resources with which you can advertise to, let's say, 3 people. So you cannot advertise everybody here, you can just advertise 3 people. So the question is, which should be these 3 people? Maybe these three, or maybe these three, or maybe these three. How should you choose these people so that you can create a maximum influence, so that you can get maximum people adopt your product? And again, solving this problem is has again many facets. So one facet of it is then again completely theoretical. So if you are a theory enthusiast, you know, let's say optimization and approximation algorithms, you can choose one path. So one path to solve it is, which is very much well accepted study in this direction, is a greedy approach. So greedy approach is something very simple. I'm just tempted to tell you. So it says that you already know the independent cascade model, right? And you can simulate it. So maybe you just take one person, maybe this guy over here, and simulate your independent cascade model and see how many people you can infect till the end. So what is the maximum influence you create if you start here with this node, right? And then check it with this particular person and do it for every single person. So and then see which person creates the maximum influence. Whichever person creates the maximum influence, add that add that person to your list. So you have one person, and so you have to choose 3 people. You have chosen one person. Now you have to choose second person. Now maybe let's say you chose this person as the first one. So you include this person over here and see both of these together how much of influence they can create. Both of these together how much of influence they can create. And again choose the person who creates the maximum influence. So you can see that it is a greedy kind of an approach. And if you go more theoretically into it, you can actually prove that optimizing such a problem is NP complete, and you can actually find out the approximation factor. And then again, if you are not a theory enthusiast and you maybe want to do something which is a little bit easy or which is more fun to do, you can consider centrality measures. So centrality measures is nothing, it tells you the importance of a node. So let's say degree is a centrality measure. So maybe initially you are just thinking, and you might think that if you start with the people who are having maximum degree, more friends, if you take such people and advertise your product to them, maybe it will reach the maximum number of people. So you do an experiment with degree. But then I come there and I tell you that may not be degree, maybe you should use betweenness, because such people, they tend to connect different parts of the network. So don't use degree, use betweenness. In fact, the people who have the maximum betweenness, advertise your product to them and then see what happens. So we don't know what will happen. So here you can play around with the data, use degree, use betweenness, and then ultimately you might find that this is the coreness factor, K core, which plays its role here. So you can do such kind of experiments. Another direction is predicting and inducing virality. So let's talk about predicting virality. So predicting virality is more about, let's say, an information is traversing on a social network and a new video has started, and you want to predict whether it will go viral or not. So again, to solve such a problem, so this is just a problem statement. In social networks, everything is like this. You have a problem statement and then you can have your own ways to solve it. So you have a problem now here, predicting and inducing virality, and your ways can be multifolded, as I told you. So you can approach a theoretical approach, you can adopt a theoretical approach, you can adopt a practical approach, or you can actually try to simulate it and see. So I'll show you through this example. You can solve this example through a variety of ways. So the first one, this is a very well-known study and it's quite easy to do. So you can do it based on something web-based experiments. So what a person did, so first question was whether there is something known as virality. So the question was, is it like it depends on a product, there is a product, and is it something that if a product is very good, very nice and very nice features, its content is very good, it will become viral, or there is nothing like that. So just to check this, one person has conducted an experiment. His name was Damon Santola. What he did was, he created a website. He created a website, and the website was for songs where people can watch songs, download them, and rate them. And then he wanted to see whether there is something called virality. So he did this smart experiment. What he did, okay, what he did was, he created artificial environments. How should I state it? He created four different experiments actually, four different worlds actually. So when so let's say you are a part of this website, you go there occasionally, you go there regularly, and you watch songs and you download songs. So there are four worlds there, four let's say chambers there, and you will belong to one of those chambers. So all the people who are a part of this website, they belong to some chambers, one out of these four chambers. And the people in one chamber, they do not know what is happening in the another chamber. So whatever music is getting popular in one chamber, second the people in the second chamber has no idea, and then the people in the third chamber doesn't know what is happening in the first, second, and fourth chambers, and like that. And then it was shown that in different chambers different things became viral, which actually means that maybe virality is not very much content dependent. And now my aim of telling this to you is not that what happened, what was the result of this study. It's just making your minds wet to show you that these kind of experiments you can also set up. So you have so maybe just a question pops up in your mind that maybe she keeps talking about virality only, whether there is something like virality there, maybe there is nothing like that. So you can conduct such an experiment and see what happens. So again, it's up to your creativity. And then you can actually use the real world data, Facebook data. So if you have some data of information spreading, you can use that data. So people, they look at the photos which are getting shared on Facebook, and then looking at how these the features of these photos, how they are getting shared. So I would rather put it this way. Let's say you are a machine learning enthusiast, and then you want to use your machine learning technique over here. So you can take different photos on Facebook and then maybe associate different features with them. Features like whether it's a, let's say, bright background or a light background, how many people are there, or who are the initial people who are sharing it. Like this, you have a number of features, and then you look at which photo becomes how much viral, and then you can figure out that which are the features which are the most important in determining whether a photo gets viral or not. And this is the example for just a photo. You can do it for a photo, for some text, where you can use some sentiment analysis also. Okay. Yet another way to solve it is using simulations and network structure. So again, we have discussed it before, right? I want to induce virality. I can tell you, maybe if you start from the highest degree people, then your virality will be the highest. Or maybe if you start from the highest betweenness people, then your virality will be the highest. So you can actually collect some real world network, do such kind of simulations, and then check how does something go viral. Okay. Okay. So this was more about information diffusion. All these threads were related to how does information spread on social networks. What can you do there? I'll now give you a different flavor of certain other problems which I am not into, but people address them and they are actually quite popular. So one of them is one being addressed by my friend in my research team, and I would put it maybe I can put it as better as her, but I'll try it. So it is something you can name it as a global versus local problem. So what is it? We have talked about centrality measures. Let's say, let me talk about betweenness. So all of you know about betweenness. It was there in the course videos. So a lot of applications need us to find the betweenness of a node. Let's say you want to do community detection. So you would like to know the betweenness of a node or an edge whatsoever. And then we know, let's say if you want to find the betweenness of this white node over here, we know that you need this complete network, right? So you need to know all the shortest paths between all the pair of nodes in this network, and then you will see how many of those shortest paths pass through this particular node here. So you need this entire information. So that is computationally very expensive, takes a lot of time, might take a lot of memory as well. So can we do something else? So can you approximate it? So if you don't know what is approximation, instead of telling the exact betweenness, can you tell, maybe let's say, to some degree, let's say its betweenness is zero point 0.8, so maybe you might predict 0.7. So within some factor, can you approximate its betweenness? Do not tell me the exact value, but tell me something which is closer to the exact value. And then when you do that, do not take this entire network, maybe just consider some part of this network, maybe some neighbors of this network, to maybe some 1 degree neighbors or 2 degree neighbors, and then can you predict its betweenness? And you can do it for other centrality measures also. So if I talk about k core or the coreness of a node, so that also demands the entire network. So can you now easen this problem by just considering the local information and predicting it instead of exactly telling me the value? One more, and now you can always create problems. So this problem mainly, let's say, exists for centrality measures. So now it's our work to extend it maybe one level upward and then see where we can take it. For example, let's say you just know this problem in centrality measures, that for finding out a centrality measure, I want to use some local information. Can you actually see I can extend it to community detection as well? So again, there are a lot of applications where you need to know whether two nodes, they are the part of same community or not. And again, for community detection, you need the entire network. So again, then can you come up with a smarter approach where instead of using the entire network, you just look at the locality of two nodes and predict whether they belong to the same community or not. So this way you can design your own problems as well, instead of working on the already existing problems. So social networks is one such subject where there is a huge scope of defining your own problems and solving your own problems. Okay. And yeah, this is something which is very interesting, and again, one of my friends is working on it. It's anonymization and distributed networks. So let me put it this way. Assume you are a part of a company, and then we know in company environment sometimes some people hate each other or do not like each other for certain factors, but they cannot explicitly state that I don't like person X or I don't like person Y, right? But let's say for a manager of the company, or for the let's say head of the company, it might be very important to know how many people hate each other. So he might not want to exactly know who hates whom, but maybe he wants to know something like most of my employees hate each other or nobody hate each other, because this has a direct impact on the productivity of the company. So what can we do in such cases? So such networks, we can call them as distributed networks, because we do not have the complete network picture. So this person over here, so it's actually not a hate network, it's a crush network, what she calls it as. So crush network, nobody wants to reveal their crushes as well. So this and you might want to have a crush network of your company, or let's say of your class, to make some conclusions. So this person over here, he might have a crush on this lady and this lady, and maybe this lady has a crush on two people or something like that, right? So everybody know their own crushes, but nobody wants to reveal them, so we cannot have the entire network. So can you come up with an approach over here where you can take you can just somehow collect this information and then reveal to these people what does the network look like? Obviously these people do not want to reveal who their crushes are to each other. So can you put this entire network here, that this is the network look like, and and in this network you do not tell them the names. So basically there are black boxes at the place of these people, and you just tell them that this network looks like this. So person A has a crush with person B and C, but you do not tell them who is person A, who is person B, who is person C, right? So how can you do that? So one way to do that is to use a third party. So maybe have a trusted third party which kind of collects information from everybody, and then give them some fictitious names and then puts it in front of them. So that might not always work, we might not always have a third party. So in that case we have a different kind of an approach which is called multi-party computation. And then if somebody is interested in this problem, you can look at multi-party computation, what it is, and then start off from there. Link prediction is something we have again and again discussed about. So I think that you already know what is the problem all about. So let's say you have this Facebook network over here, and Facebook wants to suggest you who can be your next friend. So there, this problem is called link prediction. So I have this network over here, and I want to say that most probably these two people will become friends soon. So this is called link prediction.